Sound is created by a vibrating object. For example, when a drum is struck, the flexible skin of the drum vibrates. The compression and expansion of the air on either side of the vibrating membrane produces differences in air pressure. The pressure differences generate a sound wave that moves outward from the drum's surface. Sound travels as a wave through a medium, such as water. Sound actually cannot exist if it doesn't have a medium to travel through. A sound wave is an example of a compressional or longitudinal wave. The particles in a longitudinal wave move parallel to the direction in which the wave is traveling. A sound wave alternately compresses and expands whatever medium it is traveling through. The places where the particles are compressed are regions of high pressure. The places where the particles are pulled apart are regions of low pressure. Scientists measure and describe underwater sound using terms such as amplitude, frequency, wavelength, and phase. A sound wave's amplitude relates to changes in pressure. As amplitude increases, a sound is perceived to be louder. As amplitude decreases, a sound is perceived to be softer. The average amount of energy passing through a unit area per unit of time in a specified direction is called the intensity of the wave. Sounds with higher intensities are perceived to be louder. Relative sound intensity levels are usually given in units named decibels. A wave has a repeating pattern. One complete repetition is called a cycle. Frequency is the number of cycles per second. If the frequency of a sound is increased, there are more cycles in a second, and a higher pitched sound is produced. If the frequency is decreased, a lower pitched sound is produced. A high-frequency sound has a shorter wavelength than a low-frequency sound. The wavelength is the distance from a point on one wave to the corresponding position on the next wave. A sound can be a tone at a single frequency or a combination of energy at many frequencies. It is important to understand the frequencies of which a sound is composed, but also a sound's phase. Phase specifies the location of a point within a wave cycle of a repetitive sound. When two sounds of the same frequency are in phase, their amplitudes combine. When they are out of phase, they cancel each other out. And this is the same principle behind noise-canceling headphones. Sound travels about 1,500 meters per second in seawater. That's approximately 15 football fields end-to-end in 1 second. Sound travels much more slowly in air, at about 340 meters per second. Sound gets weaker as it moves away from the source. To visualize this concept, think of a rock thrown into a pond. You see ripples, but these are caused by energy moving through the water. The ripples generated by the rock get smaller in height as they move away from the place where the rock fell, the source of the waves. The same occurs with sound waves. A sound wave gets smaller or loses energy because it spreads out, or spreading loss occurs, and because some of the wave's energy is absorbed. The ocean is filled with sound. Background sound is the sum of all distant sounds in the ocean. It's called ambient noise. The primary sources of ambient noise varies in different regions of the ocean and can be categorized by the frequency of the sound. Source level is the intensity level of a sound source at a distance of 1 meter from the source. Source level is measured in units of decibels. Sound waves in water and sound waves in air behave differently because of the physical differences between air and water. The intensity of a sound wave depends not only on the pressure of the wave, but also the density and sound speed of the medium through which the sound is traveling. Sounds in water and sounds in air that have the same pressures have very different intensities because the density of water is about 800 times greater than the density of air. Sound levels given in decibels in water are not the same as sound levels given in decibels in air.